This is the brand new Creality Ender 3 V3, and in this video I'm gonna answer the question, is this potentially the best beginner 3D printer in 2024? Let's get started. Hello my friends, welcome back to the Crosslink channel. Thank you for tuning in. Yet another video about a 3D printer, this time the Ender 3 V3 by Creality. Even though Creality has sent me this printer for free, this is still a completely unbiased and my personal point of view of this 3D printer. The good, the bad, the ugly. Stay tuned for all of the good stuff. We did not make the usual review here. We didn't print so many test prints except this first Benchy, which we did during the live unboxing and first test print on my channel. So if you missed that, maybe check out on my channel all of the live streams that we did on this printer, and also the live streams about the assembly of the huge printing project that we did with this 3D printer. Don't miss that. I don't want to forget to mention the sponsor of the material, which is 3DJ. Their Creality is really high quality, very affordable material. They sent me the 8 kilogram for the 3D printing project that we did. I've also included a 5% discount voucher down in the description of this video if you purchase anything on 3DJ's website. And if you use the links down in the description, I'm also getting a small commission for anything that you buy on 3DJ. So thank you for using those links. I also want to highlight that we're giving away the Ender 3 V3, but how does it work? You have to go on my Twitch channel and watch the live stream on the 31st of August to get into the giveaway. You will earn Nozzles, which are the loyalty points on my live streaming channel, to spend them on the giveaway if you want to enter. Instead of making so many long form videos, I'm more into live streaming at the moment because of time constraints and the project that I'm doing. I want to take you along the path with me and enjoy your company in the chat. And we're doing awesome giveaways every single month. You can also watch the live streams on YouTube, but to participate in the giveaways you have to be watching on Twitch. So with that, I want to thank you for subscribing, liking this video, and let's get back to the video. So let's start at the very beginning when I was unboxing and setting this printer up for the first test print. We had no issues whatsoever doing this. The printer started up, we did start the first test print, and we got out this first Benchy print, which just looks nice. It was printed, I think, in 18 minutes. There's also a video about that in the links down below. We also connected this printer to Orca Slicer, and to make this happen we had to run a script that's an open source script on this printer to make it open to any other printing software, because normally it's only printing with Creality Print, which I really don't like so much. The software has so many limitations and little bugs that are annoying that I would say, why does Creality simply not use Orca Slicer and support that instead? Again, to open this printer up for more connectivity, we had to run the script on the printer. I'm gonna make a video about that, how that exactly works, because that's too much for this video. But what I can tell you that it was a matter of a couple of minutes to do that. And now this printer has the full power of Clipper unleashed and more features than before. So what is this huge 3D printing project that we use so much filament for? Let's get this on the table. But before that, we have to take the printer away. Honestly, this is so large, you won't believe it. This is so heavy. This is the fully 3D printed 3D printer enclosure by Printable Accessories. It took me a couple of weeks to print this with some interruptions. I think over 150 screws to build this. We did this in the live streams, and we have 4 acrylic panels here for the side, the back, the top, and 2 doors at the front. Actually, before we put the printer in, I want to show you a few more of the details about this enclosure. So we have doors here at the front, double-sided doors which have magnets, so when you close this, magnet's gonna hold them in place. We have 3D printed print-in-place hinges. I'm curious how long they gonna hold up. Anything is besides the acrylic panels is 3D printed. On the back of this, we have openings for running the cables through. Now, why do we have this little slider here? Because there is a ventilation opening, so we can suck out the air of this enclosure while we're printing something like ASA, ABS, or anything that creates toxic fumes. And this can be as well closed if you don't need that. And we have this little lid here, so no air comes in through this hole. We want the air to be coming probably at the side of the doors. There's a little opening, so we want a real airflow through the case. That's why we want to have this closed as much as possible. Besides that, on the top, which you can't see fully, but there is a little opening here that I cut through to let the filament run in if we want to feed the filament from the top instead of using the printer's filament spool holder, and that might be usable for bigger printers. Now, coming back to the Ender3 and how it fits into this, the inside volume of this is 65 centimeters in each direction. That should usually be enough for a standard size Ender3 Bedslinger 3D printer. So let's put the Ender3 in and see how it performs inside. And that was also the reason why I wanted to print this bigger volume version of the enclosure, so you can easily put the printer in with the spool and nothing gets in the way. Now you can imagine if you want to put a bigger 3D printer inside, you would probably have to remove the spool holder and run the filament either from an external spool holder here at the top or on the side. You can also hang a spool inside. There is a couple of attachments for this project available already. So you have multiple choices how to feed the filament to the 3D printer, and something like a 300-ish size bed should still work. However, you could run into issues with the bed slinger pushing this cable that's always coming out at the end of the print bed against this. So we probably have to run it to the side. You would probably have to make some modifications on a bigger Bedslinger 3D printer. One of the questions that comes up quite frequently is, how loud is XYZ 3D printer? The one thing that is actually annoying about the KE and again about the V3 is that once you turn this printer on, the fans of the power supply and also the electronics fan are always running and creating noise. It hasn't improved with this new version. But what is also particularly annoying a little bit about this printer is that it's also very loud, in my opinion, very loud while it is printing. It's also due to this new Core XZ setup, which isn't exactly silent, surprisingly not silent. Let's watch this little video where I put the printer in the enclosure and had it running with the doors open and the doors closed. So you see, enclosing this printer with such an enclosure that is a little bit sound dampening makes a huge difference in the noise levels. And it's highly recommended if you want to run this printer anywhere where you are actually working. Of course, if you do some research, there is cheaper options available versus this 3D printed enclosure. You can build something from wooden panels. You can also buy something that is basically just cloth, but that's not gonna reduce the noises so much. Finally, how do I like the print quality of this enclosure? We have to say that I printed this with a 0.6 millimeter nozzle, not the 0.4 that came with the printer, and we're talking about nozzle swapping in a second, and I really like the results. I think that printing on a fast 3D printer nowadays with a 0.6 millimeter nozzle gives you some advantages. You can potentially print a little bit faster and still have a good amount of quality. Some people will debate me on that and say only the best quality with 0.4. I say with 0.6 millimeter nozzles you can still get high quality prints faster, and when you are printing something like this with 8 kilograms of material going through the printer, this is definitely worth it. So let's come to the most important question, for me at least. How did the printer perform throughout the weeks printing these 8 kilograms of material? Was there any severe issues? I was actually anticipating there would be things like nozzle clogging and any other things that I've seen on other printers. I've seen so many things, and to my surprise, honestly, nothing of that happened. I had a few problems where I wasn't cleaning the build plate properly before the print started. So I had some prints detaching, but that was a super small amount of prints. And all of the other prints that I did, all of the other parts that we printed for this project came out nicely without any issues. So that tells me at least printing such a huge project is absolutely possible with this 3D printer. It's very reliable. It just does the work. Now, the other question is, did the new setup with the Core XZ gantry system, did that make any difference to me? Did that change anything for me? And I would say I didn't even think about it anymore. I didn't realize the difference in print speed or something. It just performed well. So I can say, yes, the printer worked. Would I say that it's so much better than the KE? Potentially it has a better cooling system because now it has another blower fan that adds additional airflow. So potentially the part cooling is improved on this printer. What is really different about the 3D printer besides the Core XZ gantry system is the new nozzle system. So let's dive a little bit into that. So if you've seen my previous video about the Ender 3 V3 KE, I told you that it is using the K1 nozzles, which are a little bit longer volcano style nozzles, and you can get them also third party already very cheap. And after that printer, Creality introduced what is called the unicorn nozzles. This is how the unicorn nozzles look like. This is pretty much what Prusa did with their new nozzles on the Mark IV and also the Revo systems. So instead of having the throat and the nozzle separated, these are kind of pushed together. They're not exactly welded together, and that gives us the advantage that the nozzle will never come apart and no filament can escape that path while it's going through the hot zone. That was always an issue with the older Creality printers, where we had even the PTFE tube directly touching the hot nozzle end, and while that was a little bit separating during longer prints, there could be escaping some filament to the side, and that could create nozzle clog. So nozzle clogging is definitely gone with this kind of setup. Now, swapping the nozzle is supposed to be fairly easy. I've shown you this on the Creality K1C. You just unscrew the nozzle from the printer while it's cold. You screw in the new nozzle. There's no need for hot tightening, and then you're good to go. However, on the Ender 3 V3, there's a small but significant difference to unscrew the nozzle. There is an additional grub screw in the hot end that's holding this part in place, that's actually pushing against this little brass ring here, and it's securing the nozzle even further. That doesn't exist on the Creality K1C. There's nothing in any of the manuals about this, and I didn't know that, so I started unscrewing the nozzle, and what happened is it was still holding this upper part in place. The separation of the nozzle happened. I'm not sure if this is repairable, if I just can use a hammer to bring them back together. Basically, you can stick them in here, you can stick them back together, but I'm not sure if this is going to be sufficient to run this over a long period of time. Nevertheless, that was a lesson learned. You have to find that little grub screw. The opening is on the right-hand side of the extruder if you're looking at it from the front. You have to unscrew that little grub screw before you do the unscrewing of the nozzle. Otherwise, you're gonna break it apart. Creality didn't mention that anywhere. It's also not written on the package of these nozzles. So you have to be super aware that this might be an issue on your 3D printers. You always want to double check if there's anything holding these kind of unicorn nozzles. So that contradicts a little bit the concept of quick swapping the nozzles, because it takes more time to do this. While I did this and while I broke this thing, I decided that I'm gonna go for the 0.6mm nozzle. Creality was also sending me this full package of different nozzle diameters. So there's two 0.4 nozzles in this package, one 0.6 and one 0.8mm nozzle. If you want to get additional nozzles for your 3D printer, either for the K1C or the Ender 3 V3, these new unicorn nozzles are now available. I'm also going to link them down in the description of the video. I also want to show you another issue that I realized. It didn't put a real issue to any of the prints, but it is still potentially an issue. So to show you this, I'm going to get the printer out again. Oh my goodness. So the issue in question, we have this new Core XZ setup, and that means the hot end is moving freely along these two axes without tilting the printer. Now what happens during the homing process, for example, is that this whole gantry moves up completely to touch this little sensor here, which is the X and stop switch. What you realize here is hopefully that the PTFE tube that's running the filament straight into the extruder is bending when this is happening. It's bending back. Normally it should come in straight from the top, but when the homing is happening, it's bending back. This can cause the filament to break, especially if you're using these special filaments like carbon fiber filaments or wood composite filaments. If the filament tube gets bent that much, now this is a direct drive, that means it is loading the filament, it's pulling the filament into the extruder, nothing is pushing the filament, and if it breaks right here, basically the filament is running out in that very moment. Creality could have designed this differently, where the filament sensor and the PTFE would be running in the front, so there wouldn't be that kind of potential for the PTFE to bend that much. That's definitely something to watch out for if you have older filament, brittle filament. I mean, not only these special filaments can break if they are not properly stored or just not being used for a longer period of time. PLA can get brittle, PTFE can get brittle. So it is definitely something that you need to check before you start printing. Try to bend the filament and see if it's still flexible or if it's prone to breaking. Now, one last thing that I want to show you here is one design decision that Creality made, which is making me a little bit questioning if this all makes sense with the filament spool holder here on the side. Once the gantry moves up, and that happens actually 2 times during the homing process, you want to be there when this happens. You want to be there when the printer does the homing to check whether the filament jumps off the spool. And how could that happen is the spool is sitting right here, it's not moving, but the whole gantry during the homing process is moving up, and you see the filament gets unwinded from the spool. Then this whole thing comes down again, and you already see the filament is getting loose here on the filament spool because it's of course not rewinding. And this actually happens twice, so there is more potential for the filament to come off the spool. Now Creality is delivering this additional spool attachment tool, or this thing here, that is supposed to prevent this problem from happening. So you have to set this over the filament spool, over the spool holder, click it in place. That can help to eliminate this problem. However, I still managed to have some filament winding up here in the inside of this, tool. It still basically just prevented filament from going into the extruder and the print failed. So you want to be there when the printer does the initial homing, and you want to rewind the spool manually. And then once the print really starts, you can go away and be safe. This is definitely something in the startup procedure that makes it more dangerous to leave the printer unattended. One way to circumvent this whole filament spool holder problem, filament running problem, is definitely to get an enclosure for your filament. This is also going to prevent moisture going into the filament, especially if you want to print some special materials like carbon fiber reinforced materials. That's why Creality has also this new Space Pi dry box, which has an internal heater system that keeps your filament dry. And to swap the filament spool holder out for it, we're just going to remove the spool here from the holder. Going to get rid of the side arm. We are putting the spool inside, and we're running the filament through the PTFE tube here at the top, detach the little PTFE tube here from the filament sensor, and then attaching the PTFE from the filament dry box. And it's all connected together. Now no moisture can go in. The whole system is connected end to end. Filament rewinding is also not going to be a thing, because if the gantry moves up and down, this is simply going up and down, and nothing's going to happen inside of the spool holder here. And your filament's going to be dry always when you need it. Simply switch this thing on at the front. To get started with drying the filament, we're just going to set the filament material type, and we're going to see the relative humidities as shown here, 58%, 27-degree room temperature, and it's automatically now drying the filament while printing. So we should have it running for a couple of hours before we start printing, so the filament is prepared. Simple solution, solves at least a few problems with moisture and also with the gantry, pushing the filament back to the filament spool holder. I think this is definitely an investment that I would make long term. So let's get back to the final question. Is this printer the best beginner 3D printer in 2024? From my perspective, this printer did the job. It didn't disappoint. It is fast, it works. So the hardware had 0 issues. Okay, the nozzle swapping problem, that was partially maybe also my fault, but after doing that, after swapping out the nozzle, it worked perfectly, printed everything that I wanted it to print, had almost 0 issues. Some things detached, but you have to keep the build plate clean, that's clear. And besides these little details here with the filament spool holder. Besides that, it is probably the perfect printer for the money. Would I buy something else like a KE or an SE? I would definitely not buy the SE because the SE is not running Clipper, and I really appreciate the openness of the Clipper ecosystem. It is super easy to modify this printer, and also the KE, because both are running Clipper, and you can just open up the software with a free tool to have even more interesting features and to connect any 3D printing software to it. That's my major thing that I wanted to do this for, is to use Orca Slicer, because this is the one thing that I would say that bothers me about this printer is Creality Print. It's actually not the printer, it's the slicing program. Because that is so buggy, honestly, I wouldn't consider using it. Honestly, this is not a discussion for me. The way how it handles printing profiles, the way how it handles saving settings, and you don't really know what's happening if something is saved or not saved and when it's gonna be undone, how you revert things to the original. It is so unclear to me, it's so non-intuitive. Any other slicing program besides that does it better. I would really just go straight to Orca Slicer, which supports this printer now. And then this is actually a really, really good printer. It's fast, it does deliver the quality. Now, it is not enclosed. That's the one thing that you need to consider. It cannot print things like ABS, ASA, or the more difficult materials without an enclosure that keeps the temperature in the printer constant. And that's the reason why you either want to consider getting any kind of enclosure. It doesn't have to be that kind of hard enclosure that I built. It can also be these kind of soft enclosures, but you want to get something like that because then this printer can also print these other materials. The nozzle system can absolutely do it. The temperatures are there, so that's not the problem. It's really just the enclosure. It is worth it, I would say, over the KE to spend these few more bucks on this printer. It has a few more improvements that I like. It has also a better screen. It has a drive system that makes it a little bit faster, and potentially you can have higher accelerations. If you want to save a few bucks, you can also get the KE version. It has the older extruder with the older nozzles, the K1 nozzles, and doesn't have that kind of perfect cooling system yet. It still works very well. However, it is also not perfect. So I would say if you really want to get the latest thing, get this printer and be happy. I think this is what I can tell you. Now, there is other printers on the market. If you have a little more budget, the K1C is an option which works really nice. I made a review about that as well. And it really depends on the use case and the budget. So that's it from my end. If you like this video, please give it a thumbs up, subscribe, and also consider watching the live streams. Link to my Twitch channel is down below because we're giving away this printer and other stuff every single month, but only on Twitch. See you next time on the channel. Bye bye.